in this video, I'm going to be solving this problem. And so first we're going to just look at what the question is and what we're trying to find. So we're doing a 100-meter sprint, and we got two people running, two runners, Henry and Ben. And we see that both of them finish in a dead heat. That's a little weird, right? We see it says they both take 10.2 seconds. So that dead heat just means they finish at exactly the same time. Now we know now that delta x, their change in position, is 100 meters. And their total time, denoted by t sub t, equals 10.2 seconds. Now, we know that they accelerate uniformly in that next part of the question. And we see that Ben accelerates for 2 seconds and Henry accelerates for 3 seconds. So now we're going to just create two categories, Ben and Henry. And so the reason why we want to separate them is because each of their acceleration time, their top speed, those are only relative to them, right? Ben's top speed has nothing to do with Henry's top speed, and so we want to keep them separate. And so we see here we have 2 seconds for Ben, and so we can say time of acceleration, denoted t sub a, is 2 seconds. And the time of acceleration for Henry is 3 seconds. And that is how long it takes them to attain maximum speed, which they will hold for the rest of the race. And so we see they have v initial of 0. And they both have 0 meters per second because they start the race at a dead stop, as expected with the race. They don't really tell you that in the question. You're just sort of assuming that. So we know the time they're accelerating for. We know their initial velocity. We don't know their maximum velocity, the max speed they attain and maintain for some period of time. We don't really know what that v final is. And so we can say v final equals question mark. Oops. Right, we don't really know what their v final is. And in part B, we're actually going to be finding that final velocity. Now, what else do we have? Well, there's an acceleration of each sprinter that we don't know. And it's kind of what we're really to look at. We have a few variables that are constant to both Ben and Henry, being the change in position and the total time of the race. But then they each have their own variables. Time of acceleration, their initial velocity is the same for both. Final velocity, we don't know, and it's probably going to be different for both, and they both have their own acceleration. And so in part A, we are asked, what is the acceleration of both? And then that's what we're going to solve there. We're going to do that first. And then it says, what are their respective max speeds? What is v final for both racers? And then in part C, we're going to check at 6 seconds who was winning and by how much. So, maybe Ben wins the race, but Henry might be ahead at 6 seconds and he's going to lose the lead. And so that's why we're going to look at 6 seconds to see, what was going on in the middle of the race. So the first question, part A, what was the acceleration of each sprinter? So this is a little tricky, right? We have to find some way to relate the motion of Ben and Henry, to sort of connect them, right? We see that they each have their own v initial, v final, but there are a few variables like the total time of race and distance of the race, and that's constant amongst both of them. And so we can use those to connect their motion and to help us solve for the acceleration. So what we end up realizing is that delta x is consistent across both Ben and Henry. And we also know the equation delta x equals the initial velocity times time plus 1/2 at squared. And so we can use this expression to describe both of their motion. But the trick here is that if we look at a velocity graph, we see that their velocity accelerates linearly. And for Ben, it's at 2 seconds that he stops accelerating and his velocity becomes constant. And for Henry, he stops accelerating at 3 seconds. So how do we figure out what their total displacement was? Well, if you remember, displacement is not just the area under velocity curve, but we can really, more easily express it by using two equations. We have to split their motion into two pieces. Time period for 2 seconds for which Ben is accelerating, or 3 for Henry, and then the time period for which they are traveling at constant velocity. There's actually two delta x's, delta x1 and delta x2 for both sprinters. And so we're going to see what both of those are. So delta x1, where they have an acceleration and they both have an initial velocity of 0. So we can actually express both Ben and Henry's position, in a general function. Their variables, their input, the a's and the t's are going to be a little different. But we see that they both have a 0 initial velocity, so that first term goes to 0. And you just have 1/2 a t squared. Now that equation, they're going to have different a's, they're going to have different t's, but that one equation defines the x1 distance, the distance they cover while accelerating, for both sprinters. And the same thing works for delta x2, where we can express their distance covered as v initial, which is actually just their v final, times time. And the reason why our v initial is now v final is because we are looking at this time period. This time period starts at 2 seconds and ends at 10.2 seconds. And for Henry, it's going to start at 3 and end at 10.2. So we see that our initial velocity is really their max speed. And the time that they travel is the time of constant motion. So what we really need to be careful of is how we define each value of t. You can see in these two equations, we just wrote t. We didn't put any subscript like tt for total time or t of acceleration. So we need to be really careful that this is the time of acceleration and this is the time of constant speed. Time of constant speed for Ben is going to be 10.2 minus 2, or 8.2 seconds. And the time of constant speed for Henry is going to be 7.2 seconds. There we go. And so we need to be really careful that we distinguish between those two time periods, that they are accelerating for 2 or 3 seconds and then moving at constant speed for 8.2 or 7.2 seconds. Now both of these equations, delta x1 and delta x2, are going to help us describe the total displacement of both runners. All right, so we know that both of their total displacements, right, delta x1 plus delta x2, what is that equal to? It's equal to 100 meters, right? Because they both travel 100 meters. This equation is true for both sprinters. Now, they are both equal to 100 meters. We can actually set both of their delta x1 and delta x2 equal to each other. We just have to be careful that we don't mix up any of their variables. So let's zoom out a little bit so we can see a little more. So let's just write out the expression delta x1 plus delta x2 in terms of Ben's variables. And so we're going to look at the formula delta x1. We see we have 1/2 times his acceleration, which is an unknown variable, times his time of acceleration, which is 2, and that's squared. And then we have plus his v final. How do we find what v final is? That's another unknown. And we don't want to have more than one unknown variable in this problem, or we're not going to be able to solve it. So what we have to do is use the formula v final is v initial plus a times t. And we see that v final equals v initial is going to be 0 plus the acceleration times time. Now this time, is it time of constant speed? Is it time of acceleration? Is it total time? So when we're looking at this, we see we're dealing with how long he's accelerating, right? How long is he accelerating? That is the acceleration time, t sub a. He's accelerating for 2 seconds or 3 seconds, depending on Ben or Henry. And so we see that v final is just equal to a times t sub a. And we can use this v final in place of v final in our delta x2 equation. And so we end up plugging in a of Ben times time for a, which is 2, times time of c. So we can kind of see this 1/2 a ta squared plus a ta tc equals 100. This is just the general form. And in it, we're going to plug all the variables. This is going to be 8.2 equals 100. And so now we can solve for a, we'll call this a sub b, a sub b for Ben, and a sub h for Henry. Now we can go ahead and solve the quadratic equation for the acceleration of Ben. And so this first term can be simplified as 1/2 times 2 squared. 2 squared is 4. 4 over 2 simplifies down to just 2 times AB, plus we have AB times 2 times 8.2. So what is 2 times 8.2? That's 16.4. AB equals 100. You end up with AB equals 100 divided by 18.4. These two are like terms and their coefficients can be combined. Find the acceleration of Ben to be 5.43 meters per second squared. Now we have to do the same process. We're really just using the same equation, same general form. Now we're just going to use it for Henry. We're going to plug in Henry's acceleration, AH, Henry's time of acceleration, Henry's time of constant velocity. And we're going to find Henry's acceleration that way. We have 1/2 a sub h. And then we have TA. And TA is going to be 3 seconds this time, and that's quantity squared, plus a sub h. And then we have time of acceleration, which is 3. And then time of constant velocity, which is 7.2, equals 100. And now we can go ahead and do the same exact thing and just solve for AH again. And so we get 3 squared is 9 divided by 2, right, 4.5 AH plus 7.2 times 3, so it'll be 21.6 AH equals 100. We can combine those two like terms and get 26.1 AH equals 100. And then we divide both sides by 26.1. We get AH equals 3.83 meters per second squared. So we have found the acceleration of Ben and Henry. Now, this is just part A, right? The next step is, if we look back at, oops, don't do that. If we look back at the original question, it says, now what were the respective maximum speeds? So how are we going to find max speed? If you go back and look at this equation up here, let's rewrite it down here. V final, actually V initial plus acceleration times time. Well, now we know V initial to be 0, so we can just drop that term. But we actually know their acceleration now. And so we can say that, V final for Ben is equal to Ben's acceleration of 5.43 meters per second squared times how long was Ben accelerating? That was 2 seconds. And so his top speed is just 10.86 meters per second. Yep, that matches. And we can do the same thing. V final for Henry is just his acceleration of 3.83 at A times the time of acceleration. Put an A there just to be a little clearer. His time of acceleration was 3 seconds. And so the final velocity of Henry is going to be 11.5 meters per second. And so this one's a little simpler, right? Usually the first part to a question is going to require you to go through all these steps of setting up the problem. And once you get into the part B, part C of the question, it's going to be a little like more one-step, two-step kind of thing. It's not going to be as involved. So that getting over that first hurdle of part A can usually be pretty helpful. So now we are going to look at the last part C. Which sprinter was ahead at the 6-second mark? And by how much? And so this problem is a little weird because before, in part A, we actually looked at the position of them finishing the race, 100 meters. And then we created these like this position equation, the change of position 1, change of position 2, added together was 100. Well, now we're doing something similar where we're adding the sort of change of position of part 1, but we're not going to use all of part 2. If you remember, part 2 went until 10.2 seconds. But now we're actually going to stop at 6 and stop over here at 6. And we're just going to do a little check and see who's winning right now. So that means we are no longer going to be using the same 10.2. That's really the only variable that's changing, is we're no longer using 100 and we're no longer using 10.2. So what does that mean? How do we rewrite these equations? So if you remember, we use delta x1 plus delta x2 equals 100 meters. Well, now we don't know their distance. We don't know how far each runner is. So we can't use 100 meters. And so we're just going to use something like delta x, their position. And so we know delta x1 was 1/2 a time of acceleration squared. And delta x2 was a time of acceleration times time of constant speed. And that's equal to the change in position. And now this equation, we can use this to determine if we know the acceleration and we know how long they're accelerating, ta, and we know how long they are traveling at a constant velocity, we can figure out how far they got. Now we're going to have to apply this equation twice, once for Ben and once for Henry, but all we have to do is plug in all the numbers, calculate delta x, and we can compare, how far ahead one runner is. So let's start with Ben. We know 1/2. What was Ben's acceleration? It was, let's look up and see. Ben accelerates at 5.43 meters per second squared. We're not going to use the units. T sub A was 2 seconds. That quantity is squared plus the acceleration again of 5.43 times the time of acceleration. Now here's where it changes. Remember last time, we look up here, our T of C was 10.2 minus 2. But for this problem, we have to change it up. We can't use 10.2 because they're not running for 10.2 seconds anymore. Now they're only running for 6 seconds. So now we're actually going to use a T of C is equal to 6 minus 2, or 6 minus 3 for Henry. That's going to be 4 seconds. And this is all equal to his final change in position at 6 seconds. And so we can plug this into a calculator. So we get delta x equals 54.3 meters, are our units for position. And now we do the same thing, but for Henry. We have the 1/2 times Henry's acceleration. Let's scroll up a little bit. We see it's 3.83. And Henry accelerates for 3 seconds. And that quantity is squared. Plus his acceleration again, 3.83 times T sub A of 3 times time of constant velocity. And here, of a 6-second run, only 3 of those seconds are left for constant velocity travel. And now we're going to plug this into the calculator and see what we get. So here, we're going to end up getting 51.705 meters. Now, you can see Ben is winning. Ben is ahead. That is part of our answer for C. We know Ben's winning. Now we have to say, how many meters ahead is he? Well, he is winning by 54.3. You subtract Henry's distance to find the difference between the two runners. And we find that to be Ben is ahead by 2.6 meters. Now you might have a slightly different result from 2.6. I found in the calculator 2.595. People have found 2.62. And that's usually just a result of some slight rounding error. And so what we've done here is we have found the acceleration of each sprinter. We have used that acceleration to find their top speed. and then gone back and used their acceleration and the times of acceleration and constant velocity, and we can figure out where they are at 6 seconds. We can see who's winning. See, Ben was ahead at a point in the middle of the race, and then Henry caught up. That's why this is kind of an interesting part C, right? It gives you some context to the problem. All right.